Okay, today we're working on Module 7 and still doing some turning. And I'll show you what this little part looks like. We'll just kind of do a quick tour around it. All it is really a little thumb screw. We'll probably do some type of knurling, some type of pattern on this outside edge just to give it a little bit of traction on the outside. Haven't really decided exactly what that's going to be yet. So I just left it open, or just left it blank right there. I've got a drawing for you. It's pretty simple, pretty straightforward parts, 2 1/4 inches long. These threads are 3/4 of an inch long, and they are 1/4 20 threads per inch. And that's really the thing that we're working on today. It's kind of our main topic is turning threads. So we've got a 3/4 inch thick head. We've got 50 thousandths chamfers throughout the part. 900 thousandths on the outside diameter, that's on this head. Then we come down to 500 on this. We've got 100 thousandths radius here. Full thread as far back as we can get. What this is we actually broke the back side of the boot on one of our water skis. So I retrieved the back of the boot, but I wasn't able to retrieve the screws, so I've got to make some new ones. So I thought this would be a good project to make out of aluminum or brass, stainless, something that's not going to rust or corrode. And so I thought it'd be a good one to bring in here because we needed to work on some threading as well. So this is kind of what the end result of the part looks like. And if you notice, I've made the part just a little bit longer stockwise. One other thing that I want to work on today is not only the threading part of it, but we're gonna chamfer this on the backside using our 35-degree profiling tool as we turn it, but also I want to come in and use our parting tool to just clean up that chamfer, just to make sure that chamfer comes out good on it as we go. So that's what we're going to work with. We're going to be working on a piece of 1-inch stock, and this is hopefully a part that I will probably won't make it this week, but I'll probably make it probably at the tail end of next week. Definitely before I go out on the water again, because it's going to be hard to do it without it. So let's go ahead and get started. This is going to be module, this is actually going to be module 7, and it's named module 6 in here, but it's going to be module 7. It's our second turning module, okay? So we're going to go in and we're going to start a new design. And we'll go ahead and just name that thing now, and we'll go module 7, and it's actually turning 2. Okay, and it's in the 134 file folder. That makes good file location for me to be able to just go back and grab that. And I can't emphasize to you enough how important it is to just make sure you're doing some good file management and where you keep your programs at, where you keep your drawings at. You know, I try to keep all of my stuff cloud-based. I try to not allow it to go onto my machine at all. And I like to have my parts so that they are pretty fluid, so I can go wherever I need to and just kind of work on parts wherever I'm at. Okay, so let's go ahead and open up some of this stuff here, and I opened a sketch and then closed it. So I'll flip it around here, and I want my z-axis working this way. I go ahead and just, this is personal preference, I kick Y up and then I run Z across there. When you get to the manufacturing side, you're going to make those changes anyways. So if you've already printed out the print, or you've got the print on a second screen or something else, then we're going to go ahead and just start working this thing through. So it's about 2 1/4 inches. Actually, it is 2 1/4 inches long. So I can come along here and I can just go 2.25 and take that line there, and if I want to just go ahead and kind of just make a shape for the rest of this thing, I can. See, we got our threads that run here. Step up, and then we go up. Let's see, I'm gonna go ahead and just take that on past. Take another line up here. It is parallel hit it there. I'll trim this out. This gives me my, kind of just my overall shape of the part. Get some of this out of the way. I'm working remotely today, so I've only got one screen. I got to do everything just in the laptop screen itself, which makes it pretty hard because I've gotten pretty used to working in multi-screen. So I'm going to bring this head out to 3/4 of an inch, and I'm going to make these threads, this threaded section 3/4 of an inch. And then this one by default becomes 3/4 of an inch. And so my outside of my diameter becomes, this is going to be on half. So it's 0.45. That would make 900 thousandths in diameter. This is going to be 0.25. And then this will be, come out here and we'll go 0.125. Okay. So bring that in. I'll go ahead and do a quick save. So I've got that thing sitting there. I probably won't put my chamfers in now. I'll wait till I do, till I make a model out of this thing. But I will go ahead and put my radius in the corner here. So come up here, go to the radius, draw it in a little closer to me. Instead of 30 thousandths, I'm going to go to 100 thousandths. So it doesn't come quite to the edge. One of the advantages of doing a larger radius like this, I mean, for me, I need a radius on the front of the part so they can go into the little nesting section that needs to adjust the ski. But the more chamfer, angle, or draft that I can put on here, the further along I can go with my threading. Keeps me from having to stop way back here. And so we'll look at a couple of those things as we go along today, about how to make sure those threads go back as far as you want them to. Also how to touch off the tool, and so we make sure that we get some quality as we go through there. So really this is the outside shape of my part. I should match what I've got here or here. And it's true I don't have any threads on it yet or chamfers, but those things will come here in just a second. So we'll go ahead and finish the sketch. Go ahead and do a revolve along, let's see, we'll go with this profile, and we'll go with this axis. I love the way that Fusion's kind of starts to default to kind of know what you're doing for most things. It's pretty accurate on most stuff. So I've got my part now. I do not have chamfers on it, so I can go ahead and come into modify and hit chamfer. And I want to select the edges. I'm going to select this edge, I'm going to select this edge, and then I'm going to come along and select this last edge. I'm going to go 50 thousandths. They're going to be equal distance on both of those because chamfers are 45 thousandths, or 45 degrees, sorry. And so that takes care of my chamfers. You can see down here I've got very small amount of just flat surface there, and that's what I'm talking about, where it's going to help me to pull that thread back just a little bit further. All right, so I've got my shape, I've got my chamfers on, got a pretty good setup now. So what I'm going to do is go ahead and come down under Create, and I'm going to hit the Threading tab, and I'm going to select the faces, which will be this diameter that I want to thread. Fusion already knows, due to the fact that my outside of my dimension here was 250 thousandths, it knows that I'm going to do, or making the assumption that I'm going to do something that was a 1/4 inch. And so it's going to come in here and say, you know, is your size 1/4 inch, 1/4 3/8, right hand. So you can go right hand, left hand, if you want to do a left hand thread there. And you can model those threads. And so if you model those threads, I think that the temptation is to do modeling because it looks better. If you do that, you're going to have a little bit of problem when you're outputting your code, because what it's going to see is the finished product. And as it does that, it's going to try to turn, let me zoom in here. It's going to try and turn this area, and then turn this area, and then turn this area, and turn this area, and while skipping all of these sections here, even though you haven't threaded those yet. So for 3D printing, we'll leave modeling on. For just our 2-axis turning operation, we're going to leave that off. Now, on this, I do think I want to try and grab as deep of a thread as possible. Now, all of this kind of depends on how you touch your tool off. I will always touch the very front leading edge of my tool off on the front of my part. So it's if I thread back 750 thousandths, it's only going to just touch this face. If you were to do the center part of the V, then you can expect it to go back half of the insert more and actually just kind of plunge into this face. I don't want to do that. I think that's really a bad practice to go, because I think it makes the code appear as though it's doing something safe, but it's not. So my recommendation would be to always touch your tools off on the very front leading edge of that part. Now, if I want to go to a different length and I don't want to thread it all the way back, I've got a couple of options. I can just drag this arrow back and forth here and kind of get, so say I want to go 5/8 of an inch. So 625, thread that back 625 thousandths. It's going to leave me 1/8 of an inch back there. Now, I can also offset the threads up or down. So if I want to do that, if I want to thread them up, I've seen some parts that look like that shouldn't have. And so, I don't want to do any kind of offset there. I don't want to change that. I would allow this. This would not be that big of a problem. I could also go maybe 700, give myself just a little bit more, or maybe 675. Give me just a little bit of edge on there just to make sure that I don't come across that. And that's just a little bit of just kind of user preference there, or what the manufacturer of the print is denoting on there, so how far back you're going to go. One thing I don't want to do on this, especially in a small thread like this, I want to try and get away from having an undercut unless I'm bringing in some undercut that has some radius, because what you're actually getting from this, anytime you got this corner here, this 90-degree section, you're creating a breakpoint. I want to try to not have any kind of breakpoint on something like this. So really, it might be a little bit better to even go in and give that thing just a little bit of radius. Now, I'll already have some radius built into it just because of my tool nose radius. But if I wanted to, I could go ahead and do a quick save and go ahead and come back in here, go back in, edit my sketch. And I'm a little twisted up, but I just need to see, just want to see one small section. I think I'm going to put some radius in right here, and I could also do that in the model, but I think I'll just do it here. So I'm going to put about a, let's see what a 50 thousandths radius. Ooh, way too big. If I go 30, 30 is really on the borderline of being too tight as well. Let's go 25, and we'll finish it there, and then bring it back in. Rotate that back around. I don't really see much of a radius on there, and so let's just make sure that we got that in there. Finish that sketch. Rotate this thing back around. Still really not left with, oh, that's not good. So we want to, definitely don't want that. What we've done is created a little cavity inside there to get that radius. And so clearly I've not put something in correctly. So let's go back and take a look at that. Oh, yeah, definitely not what I would want. So let's go back a couple steps. There we go. And let's just try to redo that. See if we can't get a nice little radius in there. Something. Whoop. It was something in the corner to just kind of help us out. 0.025. I think possibly before I might have put 250 thousandths instead. So whoop, nope, still too big. So let's go back from that. My tool itself, I think, is a 15 thousandths. It's either 15 or a 30. I'll have to go back and look. So now I've got some radius there, 20 thousandths. Won't be a lot of radius, but it'll be some. I think that is a good thing to put in there. So that gives me 20 thousandths radius there, very, very small flat area right there. And so even though my tool is 15, 16 thousandths, if I were to accidentally grab or something come along that would cause me to change and have to use a tool that was different than that, maybe a 7 thousandths tool nose radius, I've already got this programmed in as being 20. So that way I make sure that I don't end up with anything less than that. So while I'm here, let's go ahead and go back in. And let's do some modifying here too. So, I mean, if we're going to do one radius, we might as well do another. See what 100 thousandths radius looks like there, and we'll finish that. And that's a pretty good looking part. This part's out in space, so it really doesn't matter if it's got some radius in there or not. I think this is bulky enough, it's not going to be an issue. Since it's just a thumb screw, you're probably not going to just bust this off. I know if you're going to break it off, it's going to be down here anyways. So we'll go ahead and leave that as is and see kind of how it looks. I'm not really planning on anodizing these red. I guess we could if we wanted to. So let's go ahead and move into manufacture and continue to try to work left to right as we can. Model's front rather than the stock front. I want this to be Z0, not the front of this part to be Z0. Okay. So really from there I can go back as far as I want, and then the one that I had showed you originally, I've got something like, oh, I've got some change behind it. Let's go back in there. I've got some dimensions behind that, and so I can take my stock back further if I want to or not. I don't have a chuck on there, so we don't really see so much of that. So you got just that's just your back part of it where it might sit at. I can make my material longer, shorter, whatever I want it to be. This just kind of gets this out of the way. I could actually have a chuck drawn in if I want to. I can use some type of fixturing if I want. I'm not going to do that on this. It won't really make any difference for what we're working with today. So we go into our stock. We are using some 1-inch stock. We are going to go off of the front of the part, so offset from the front. And so if I want my length to be longer, so say 4 inches long, it's just going to grow from the back side of that. So say I got a long bar that I'm using, that would be a pretty good representation of that. As far as work offset, I'll go ahead and use one. That's going to be a G54 as well. So we can come in here, and this takes care of the bulk of our kind of start out work here. So here we are. We've got our setup, we've got our stock, and now all we have to do is our machining. I'm going to go ahead and do a quick save. From here, I'll go ahead and start doing my machine, my NC program setup, and I can use whatever program number that I want, 2323 maybe for today, and then I can call this my ski boot screw. I can change the way that I open it. I can open the NC file in an editor if I want to, and so it's already got me set up for a Haas turning post. That's good. And I want to max my spindle speed down at 1200, even though some of my tools are going to have a higher max spindle speed. This will keep my G50 where I want it to go. I'm going to use not a simple threading cycle. I am not going to use a tailstock. I will use can cycles. I can or cannot separate words with space. For me, I don't think it's really going to matter one way or another on what I do. I will use optional stop. I do not have a chip conveyor. Today I don't think I will use sequence numbers just because it will use it in the can cycle, but that's the only place that I think it's going to. And we'll take a look at that as we go. There are no operations at this time to do. And the only thing I noticed that this says setup 2 just because I had some problems a second ago. So I want to go in and change that because I don't want to have it causes me to believe that I've got it causes me to believe that I've got some type of problem in there. So I want to get that changed so that I've got setup 1. And now I should be good to go. Hit save there. Now if you see that red circle with the exclamation point in there, it's just because there's no operations to machine yet. And since there are no operations to machine, it sees that as a problem. It's not a problem for me because I just haven't got to that point yet. So let me move my part back around, get it centered up. And so now I'm just going to kind of start to follow along left to right as I go. So I'm going to do a face off. I've got a tool that I've been using quite a bit lately, and it is going to be under my probably my SFCC tools. Maybe I have something already set up. I thought I had something already set up for some turning tools. Oh, let's go ahead and go into turning tools and see what we got. I don't see anything set up. So I have turning tools. Oh, there we go. There's one. So it's I had left it under all tools. So I'm going to use this VNMT. We can go in and take a look at it under Edit. It is a profile turning tool, and it's a Kinemetal VNMT 432, and we've talked about that before. So if I were to go to a 15 thousandths tool nose radius, we can go to a 1, and it's not really a full 15. It's like 15 and some change. So it's not really 20, but it's not also 15. So here we have just the rest of our information about our tool, cutting data. We're going to rough it at 12. Surface footage, we're going to bring it down to 600. We're going to just assume this is probably aluminum that we're working with. We will call this tool number 1, and everything else seems to be pretty good. So we'll hit OK from there, or select from there. Now we get our tool, and again, when I was talking about front edge of tool, I'm talking about the very far most leading edge of the tool, the one that's going to hit the chuck or chuck jaws first. And that's always this edge. So whether it's the turning tool, whether it's the grooving tool, parting tool, probably 95% of the time I'm using this as my Z0. So just really some minor specifications or instances where I might do something different. So this has my max spindle speed at 5,000. I've set my machine so it won't go over 1,200. I do have my surface footage at 600, so I'm good to go there. It's off of the front, so we're good to go. I'll probably go ahead and change these, bring those into 0. Probably go ahead and just do that properly. And I don't really want any kind of offset there either. So I want to just try and bring that in pretty tight to my part. I will let the computer do the work there. I could change tolerance here. Not going to make a ton of difference. As far as stock to leave, I'll leave in my roughing. Let me go ahead and leave 10 thousandths on there for my finish pass. Let's see, full retract, that'll be fine. Everything else seems to be pretty good. Lead in, lead out. I think I'm okay with about everything else that we got. You know, and now that I think about it, we'll go ahead and run a quick graphic on it. I left stock on that face, and I probably shouldn't have, because I doubt, it's so small, I doubt that I'm going to come back in and do anything with it. So let's go back in and edit that. Whoop, not change the name of it, but edit it. Let's go back in there, and we're not going to leave stock on that. So quick change there, and then we'll just do a save just to make sure we're up to date. Okay. So facing is done. We just naturally move from left to right. It's going to take that same tool that we had, and that works really well because that's what I want to use. Working left to right, top to bottom, everything should really flow about the same. And I'll go ahead and change these. I need to go in and just change that as a default because I will 90% of the time go in and change those things. I do want to leave some stock here. So I want to leave radially, I want to leave 10 thousandths. Maybe in Z I'll leave 3/1000 just for some face cuts. There's not much of a face anywhere to cut off of it. And I'll probably go ahead and change tolerance just because at this point and what we're working on doesn't really make much difference either way. Okay, and so we'll go ahead and rough that out. Flip that up so you can see it a little bit better. So for my finish pass, yours may or may not look like this, but we'll go ahead and go in and just do this finish profile on here. Using the same tool, we will leave no stock on this one. We will change feed rate though. Go ahead and go on down to 8/1000 on your feed rate. And that's a nice color. 0, and again, this could be down to 1. No stock to leave, and then we should be able to take that down to size. Everything should come out good. Now, see earlier, let me go back to this. I want to show you this undercut that we've got. You see it on the back side. It's an undercut right here. I'm going to highlight it right there. See it? What you can do is you've got radial grooving right here as an option. So if you do not allow radial grooving, it will not do that undercut behind there. So let's just look at that. Let's do not allow for radial grooving, and then we'll change that. And we will go ahead and just regenerate this as well. And now come back up here and let's do a quick graphics on it. Oh, we still have radial grooving. Okay, so let's see what's happened here. Something along the way. Oh, don't allow radial grooving, sorry. See, now we do not have it anymore. So let's go back and rerun that. Speed it up a bit. Okay, so we do have it on the finish tool, but not on the roughing tool. So you can, if you don't want those undercuts to be put in there, you can change those undercuts. You can pull those out or not. I do want them in there. I'm going to go back in and put it in there. I'm going to allow for radial and axial grooving. It's not going to make any difference here for part that we're working on. I do want to just allow it to do some roughing back there. And from at this point, I'm going to go ahead and do generate for all tools. Puts me back into place. So that takes care of my my face off, my roughing, and my finishing. I need to come in here and do a threading tool on this. So I'm going to go down to turning, and I should have a turning thread, and then I'm going to come in and just grab me a threading tool. Now, if all goes well, I've got something similar that I could probably use for turning. OD threading tool. Okay. So I want to take kind of a quick look at some tools here that I have and see what I have and what I don't want to use and what I do want to use. I've got this VNMT, CNMT, ID, OD threading. Let's take a look at it. Probably just do some modifications to it. Should have done some modifications to it. Go into edit, right click. OD threading tool. We need to switch that into inch. Okay. Everything else will be good enough. And I'm not going to use constant surface speed on this because I don't want my spindle speeding up and down. Small area that I'm cutting, and we will use it as tool 2. So 2 and 2. Actually, that one's probably 0. Tool number, compensation number, turret, and so let's just hit. Let's see what that looks like. Something to me says that that's not quite right. We're going to check that as we go, because I think, let's look at this one while we're here. Edit, post processor. Yeah, you need a compensation offset and tool number, so we better go back again and change that now. So here, edit tool, post process 2, and accept, and select. So we've got our tool. We are going to use flood. We're going to do outside threading. We are just going to do it at a constant RPM. Here's where we can confine it as far as how far back we want it to go. So even if we programmed our threading to go back to a certain distance and we want to grab it to hold it into a certain spot, or to start in a certain spot. So say maybe I want to start 200 thousandths in front of it, and maybe I want to give it some back side offset. We can do that. You'll see that here in just a second. We're going to grab our thread faces, and so maybe I want to start my thread 200 thousandths in front. Maybe I want to start it 500 thousandths in front. It seems odd. And then if I wanted to have a backside offset, I can't remember if that's negative or positive. So that'd be where I want to go from the backside. I don't want any kind of offset back there. I've already programmed it to go back as far as I want. I can apply that from the back or the front side. Obviously 500 is going to be too much, but 200 won't be bad. So we have our threads there. I'm going to go ahead and bring this down to 0 again. Here's where kind of the nuts and bolts of this works. So we can do a right-handed or left-handed thread. We can take our thread depth and then the number of step downs. I'm not taking a look right now at the actual thread depth. So that's brings me down to 210. It's probably pretty close on the minor diameter. This pitch is not right for quarter 20. So quarter 20 has a 50 thousandths pitch. So you do want to keep a machinery handbook close to you so that you can double check some of these things. This minor diameter might be on the high side, but I think that I'm going to work with it, and then I can always do some fine tuning down at the machine. I can do multiple pitches if I want. I can do double lead threads, triple leads, maybe all the way up to, what can you do? Can you do 10? You can. That would be pretty small on this particular part. You can do a spring pass, and you can use a cycle. I do want to use a cycle on this, so G76 instead of G92. Everything else looks pretty good. I've got my threading tool already picked up there. The front edge of it, this is my front edge, it's 0, okay? Looks pretty decent. Okay, let's go ahead and do a quick save. And we'll go ahead and come back up to the top and run that graphically. Speed it up a little bit. Okay, so I know it doesn't quite look perfect, but it is threads. It is the way that we want it to look. We get this nice tan's probably not my favorite color to use for something like that. I really like that purple or that magenta color. So we've got our part, we've got some radius additions added into it, and then we'll close here, go back, and then all we really need to do now is take care of our part off. And so part off is over here. We're going to select a parting grooving tool from there, and I know that I saw one, so we'll go back into turning tools. What do we got? OD grooving would work. rid of that tool. And we'll edit that tool. And the insert, we'll go into inches. Insert should be about 125 overall width of this thing. So let's just see what we've got. See what we have for holder wise. It's going to be pretty fast as far as feed rate. Let's go ahead and make that 3/1000ths. It would make this tool 4. We'll change this one to 4 as well. Let's go back to the insert. As far as width goes, this works real well, 125, 126. I don't know that it's got quite that much corner radius on it. Without just going and grabbing one, I think that's probably got something more like a 15, 16 on it. But no matter what, it's still touched off on the diameter and then touched off on the very front face, and so those variations don't matter in the program at all, really. So we're going to accept that from there. Yeah, and hit OK. All right, now I don't want to use constant surface footage on. Actually, I do. Sorry, I do want to use constant surface speed on that, and I want to run in here, and I want to take a couple looks at, or a couple. I want to look at a couple things. Really, those things are going to come right here. So we are not going to transfer stock, but we are going to use pecking. We're going to peck in depths of, let's say, 50 thousandths and a retract of 10. We're going to reduce our feed. This is radial, I believe, and we're going to reduce it at maybe 50 thousandths and go down to about a 1,000th feed rate. And I will allow the rapid retract. And so what I'm doing is when I peck down this thing, instead of going down as a face-off and not and creating a really long string, I want to go down and do some pecking so that I can have a real nice short chip that comes through there. And I want it to slow down when it gets down pretty close to the bottom so it doesn't fling out of there. Let's see. I think no stock to leave. Break edge, or edge break is the only thing other thing I wanted to look at on this. I want to put a 50,000th chamfer on that, even though I've already created a 50,000th chamfer with my VNMT back here. I want to go back over that just to clean that up, just to make sure, because that does have some angle on the back side of that 35-degree tool, and it might not be perfect. So I want to let my parting tool come in there and just kiss that thing and just make sure that it looks really good on the back side. Okay, we'll just run a grooving tool on there. All right, so what it does is it pecks it down a couple times and it comes over, grabs this, and then faces it off. That's how it'll take care of that. So it's going to go down, it's going to go over, and then go down, peck, 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 and then part the part off. Then it's going to allow it to wrap it back up, wrap it back over, and then get out of there. Okay. So that leaves me with tool 1, tool 1, tool 1, tool 2, and tool 4. I'm going to go ahead and do a quick save. Then I can go ahead and come back up here into this one, get rid of my exclamation point, and I want to do all of these operations from this side. Hit OK. And then if I like that, I can go ahead and look at my NC code. And this happened to me the other day on one of our other machines. It did not have, Fusion has a new code reader, code editor, and so I needed to install that Visual Studio Code, and it just takes a second. So you might go ahead and get that thing loaded if it's giving you that option. While we're doing that, when it comes up, I had a really hard time reading it. And so part of that is just because I unfortunately am just getting older and it's getting harder to see. So, oh, there we go. Now it should come up. And so this one's not as bad to read, but on the screen that I was working with the other day, the white letters weren't as bright. So you can go in there and you can kind of change some of those, the way you want that thing to look. So you can go white. That's probably more of what I'm more familiar with. So that's what I went with. And what I like about it is it shows you kind of page by page by page by page by page of what you got for code. That's pretty helpful. Let's take a look while we're here. Let's see how we got this G50 for 1200. We've got that, and when we highlight one, we're highlighting them all. And so then we did G54, we took care of that. We've got T101, and then we've got, when we move to our next tool, we go in for our threading, and there's our finished profile, there's our thread, C202, that was the one that we were a little bit unsure about. 54, 500, we're using a G76, we're going down, this says go down to 166 thousandths, feeding back 730 thousandths, with a feed rate of 50 thousandths, angle of 0, depth of first pass I think is 50, and then the radial value I believe is 40 thousandths. So I'm going to go ahead, and that's probably for me, I believe that's probably too low. I might go in and do a quick change up on that. Let's look at parting while we're here. So we're going to start out at 9. We're going to do a quick little run back here. We're going to go into 900, back out, then back in, then back out. Quick little radial move right there. Then we're feeding in, taking care of our parting off. I want to go in and change the threading real quick. So I'm going to go back here, and then I want to go into threading, edit it. So thread depth is, I'm going to bring this back to 1 thou. And my thread depth, I don't want to go that deep. So I went down to 166 for my minor diameter. I do not want to go that deep, that's for sure. That's going to be pretty deep into my part. So if I'm 166.166 and I go plus 40, and then plus 40 more, 246. So I'll go ahead and I really only want to go, gosh, probably 20, let's go more like 25 thousandths on that, and from there on out I can play with it, do some tweaking on it. So I'm going to save that. I need to go ahead and regenerate that. I can do a Control G and just regenerate all of them if I want to. Give that a second to catch up. And let's see. So let's take a look at the code now. Come up here, grab that one, hit that, and see what we look like now for our threading. There's our threading, 196. It's probably more like it. So we'll leave that alone right there. I don't have a book in front of me that says what my minor diameter should be. That should be pretty good though. And so what I want you to do is I will have you submit a setup sheet for this part, the diffusion file, and then your NC file, and then I'm going to attach a couple more drawings probably from Titan. that you can work on, and we are nearing the end of our modules. We just have one more module left to do, and that'll be our final. So get to work on these, and then we'll be good to go. All right, see ya.